Welcome to lessons for Monday 125. We're going to be taking a look at more radical properties, and I actually decided to split this into two lessons. So we're not going to do B, we're just going to do A and C. And this has to do with breaking them down. We talked about this on Friday, how to break down roots. We did it with numbers, we're going to do it with variables here. And then we're going to do a little more with rational exponents as well. So what we have in example A is I have a fifth root of 4, which is not a perfect fifth root, nor does anything go into it because there's no factors of 4 other than 2, which is not a perfect fifth root either. So we're not going to do anything with the number, but we are focused on the variables. A to the 8th is not a perfect fifth root because 8 is not divisible by 5. Neither is 14. Now C is already, but what do I do with that A and the B? What we're going to do is we're going to factor out the perfect fifth roots. To be a perfect fifth root, the exponent has to be divisible by 5. So what I have is a to the 8th, which is 8 a's. You don't have to do this, but I'm just showing how expanded form works. 8 a's all being multiplied. Well, I need a fifth root, something divisible by 5. So I'm going to take 5 a's and 3 a's separately. So I'm going to break it up into a to the 5th and a to the 3rd. And then B, 14 is not divisible by 5, but 10 is. 10 is the highest number of b's that is divisible by 5. So I'll do 10 b's multiplied and 4 b's. So I'm breaking b to the 14th up into 10 b's and 4 b's. Now, the first a and the first b are divisible by 5. So I've factored those out. Now I'm going to use the product property and separate them. The 4 is not a perfect fifth root. Remember, it has to be perfect to get out. So we're going to take the a to the 5th, which is perfect, the b to the 10th, which is perfect, and again, it's perfect because it's divisible by 5, and the c to the 5th, which is perfect. So we'll take the perfect ones out and divide those. A to the 5th, divide by the index. 5 divided by 5 is a to the 1st. 10 divided by 5, b squared. 5 divided by 5, c to the 1st. And then what's left over, the parts up here that were not perfect, the 4, the a to the 3rd, and the b to the 4th, those stay inside the fifth root, and that's fully simplified. Let's come down and do an additional example of that. What I have here is a fourth root of 48, not perfect, x to the 7th, not perfect, y to the 8th, 8 is divisible by 4, so it's perfect, and z is not perfect. So we're going to separate it, this time with the number as well. I'm looking at the perfect fourth roots. And the perfect fourth roots go 16, 81, but I've already found what I want. 16 times 3 is 48. So I'm going to break 48 up into 16 times 3. I'm doing each element separately. I'm going to break x to the 7th up. I have 7 x's, so I'm going to break it up into 4 and 3. 8 is already divisible by 4. And then I come to z to the 9th, so I'm going to take 8 z's and 1 z, because 8 is the highest one that's divisible by 4, highest one. So let's separate these. I'm going to pull out my perfects. 16 is perfect. Whoa, 1 second. So I'm going to pull out my perfects. 16 is perfect. X to the 4th is perfect, y to the 8th is perfect, z to the 8th is perfect. And what's left over, let me change colors, the 3, the x to the 3rd, the z to the 1st are left trapped inside. Now, you don't always have to show this intermediate step. If you can look at this step here and say, okay, I see what's perfect, I've separated it. 4 through to 16 is, well, not 4, 2. I don't know why they would put 4 there. 4 through to 16 is 2. The 4th root of x to the 4th is x to the 1st. The 4th root of y to the 8th is y squared. Z to the 8th, z squared. And we're just dividing exponents. 4 divided by 4, 8 divided by 4. So if you don't need to do this intermediate step, that's fine. You can get right from the first to the third step. And then what's left over inside stays trapped inside. So we've taken the 4th root of all these perfects, and then what's trapped inside stays inside. So I have 2xy squared, z squared, fourth root of 3x to the third z. I do, however, because it was an even root, need to put that x in absolute value. Final answer. Let's go back up, and I'm going to save example B for tomorrow. Instead of just doing practice, I'm just going to break this up. I think it'll be easier to handle that way. So we're going to do example C. And example C is more with rational exponents, which we've already done some, but we didn't do them with variables. So what I see here is 14x y to the 1/3. And down below I see another number 2, an x, and a z. So what do I do with these? Well, first of all, the numbers I just treat like numbers. 14 divided by 2 is 7. But then I'm dealing with an x unseen first exponent of 1, and an x to the 3/4. So what I have is x to the first and x to the 3/4. And I'm going to treat those separately. I'm just going to work with this right now. And I know that when you're dividing, you subtract. 1 minus 3/4 is 1/4. So I'll get x to the 1/4. There are no other y's, so I'm not touching the y to the 1/3. But then there's that z to the -6. A negative exponent means do the reciprocal, so it comes up to the numerator to become positive. So just follow your rules of exponents. We need to get a little more practice with those. It's just dealing with variables. I'm going to do one more example of that. If I had 15 x to the 3/4, y to the 1/3, and we would have 30 x to the 2/5, y to the -5/6. Alright, so what I have is 15 over 30. That reduces to 1 over 2. What I'm going to do with my x's is when you divide, you subtract. So I'm going to do x to the 3/4 minus 2/5. So we need a common denominator of 20. So multiply top and bottom by 5 in the first one. There's 3/4. Top and bottom by 4 to make 20 there. That's 8/20. That's that 2/5. 15 minus 8 is 7/20. So what I have is 1/2 and then x to the 7/20. Now let's deal with the y's. And for the y's, I would be taking, let me get rid of this just to clear room, y to the 1/3 minus a -5/6. And that's just like bringing it up, because if you were to bring that y up, it would be multiplication, which is addition. Either way, we're adding these together ultimately. So what I have then is 1/3 plus 5/6, and then obviously we're going to rewrite 1/3 as 2/6, which gives me 7/6. So I have y to the 7/6 power, and there's the final answer. Alright, you can get off and try your homework, come back to live session if you have questions.